So a rocket travels given this velocity function. First question says, how far does it travel during the first 25 seconds of flight? So one thing I like to do is to help students with ideas of derivatives, talking about velocity, acceleration, things like that, is sort of stack these on top of each other. Okay, so f of t is like a location function. That tells you where it is at a certain time. And so if you evaluate between f of 0 and f of 10 and subtract those two values, that's telling you displacement. Okay, so this function can tell you something about how far it's traveled. We don't have that though. We have v of t, which is the first derivative of the location function. And then if we had something about acceleration, that's the second derivative. So we have the first derivative here. If we want to know something about the change, we need to bump up to if we want to know something about the change in location, we need to bump ourselves up. In other words, we need to evaluate some sort of antiderivative. So this problem needs an integral to solve. We integrate between 0 and 25 for the square root of t times 10 minus the square root of t squared. And so I don't see any tricks right off the bat to make it easier. I think we just have to expand the parentheses and then write it out in separate terms. Get rid of this. So if we expand the parentheses, that's 10 times a 10 in the first parentheses, so that's 100 minus 10 squared roots of t minus 10 squared roots of t. And then square root of t, negative square root of t times negative square root of t is going to give us a positive t, because that's a 1/2 power plus a 1/2 power. Keep going a little bit more. Distribute that square root of t. Distribute it here, so that's going to give you 20t, and then distribute it here, then that's going to be t to the 3/2 power, and then from there, this is what I was doing before. From there, you can separate this and evaluate each individual integral from 0 to 25, and that will tell you how far it travels in the first 20 seconds of flight. Here's the beginning. Here's the 25th second, and we're integrating because we're talking about a change in location. How far does it travel in the first minute? Just do the same thing, but from 0 to 60. And how far has it gone when it momentarily slows to a stop? So this question's a little bit different, though. We need to know, here it starts at t equals 0, and it starts traveling, and then it's going to stop at some place. We need to know what this location is, because then we can integrate from 0 to that location in time. So how far has it gone when it momentarily slows to a stop? When something comes to a stop, that means the derivative is 0, right? If this is a graph of how fast this car is traveling, then we want to know when the velocity has hit 0. If this is, sorry, I said two different things there, so let me repeat. If we have a graph of velocity, well, this means it's going forward, going forward, going forward. This is going forward at the fastest possible rate. Still going forward, but at a slower rate. When v of t equals 0, that means it's momentarily come to a stop. But I think this graph actually looks something like that. So we want to know when v of t is 0, because we want to know when the velocity has come to a stop. So what you'll want to do is solve this algebraic equation for t, and what you're going to get is t equals 0, and that makes sense. It's stopped at the beginning. It's not currently in motion when we first start tracking this thing. You want to set each piece equal to 0, so set this piece equal to 0 and solve. So you got 10 minus the square root of t. You could say that's still squared equals 0. Solve this equation. That will tell you when it's momentarily stopped, and then you'll plug that value in here and then integrate just like we did before, and that will tell you how far it has traveled.